All right, section 6.4, solving systems of linear inequalities. This time, unlike solving systems of equations, solving systems of linear inequalities, we only have one method, and that one method is by graphing. So our steps when we do this is to graph each inequality and shade the solution region. The points where the shaded regions overlap, that's our solutions. So that when you do inequalities, there's not just one solution, but there's infinitely many, or either no solutions. We'll get there. And step 3 is to erase any non-overlapping section. Our first example is the system 2x minus y is greater than or equal to -3, and y is greater than or equal to -1/2 x plus 1. So this equation would be easy enough to graph because it's already in slope-intercept form. I'm going to first convert this first top equation to slope-intercept form. So I'm going to subtract 2x from both sides. So I have minus y is greater than or equal to -3 minus 2x. But remember, our y is not totally by itself, so I'm going to divide both sides by a -1. And remember, when you're dealing with inequalities, if you divide or multiply both sides of the inequality by a negative, you have to flip the sign. So we're going to have y is less than or equal to 2x plus 3. So this is inequality number 1. This is inequality number 2. And my suggestion when you graph these is to graph them using a pencil. Alright, when I go to graph y is less than or equal to 2x plus 3, the y-intercept is 3, and the slope is 2. Up 2 over 1, or down 2 over 1. And because it's less than or equal to, it's going to be a solid line. And remember, when we deal with inequalities, we have to do a test point. So my test point, a good one is 0, 0. When I plug 0, 0 into that, I get 0 is less than or equal to 3, which is a true statement, so I would shade down below. Okay. Now for my second inequality, y is greater than or equal to -1/2 x plus 1. Plus 1 is the y-intercept, -1/2, so rise 1 to the left 2, rise 1 to the left 2, down 1 to the right 2. Again, it's greater than or equal to, so it's going to be a solid line. Oops. And again, you have to do a test point. My test point is 0, 0, and I would be left with 0 is greater than or equal to 1, which is not true, so we're going to shade on the other side. And you will see, when we do this, I have shaded overlapping in this. See, when two lines intersect, there's kind of 1, 2, 3, 4 sections. In one of those sections, you should have 2 sets of shading, and it's in this one. So I'm going to darken up that shading, and I'm going to go back and erase all the shading of everything else. Anything else that does not have any overlapping, I'm going to erase them. So, a solution to this system of inequalities would be any point on this part of the line, because we're including it, this part of the line, because we're including it, and anywhere in between. So an example would be the coordinate point 5, 0, would be a solution to this inequality because the point 5, 0 is in the shaded region. We're only going to do 2 examples today, and our last example is the inequality x is greater than 3 and x is less than or equal to -2. So I'm going to do a makeshift graph paper. I do not have a printer at home. All right, remember, x is equal to a line would be a vertical line, so x is greater than 3. Because it's greater than, it's going to be a dotted line through the point x is equal to 3. X is equal to is a vertical line. And if we're going greater than 3, that means we're going to shade to the right. X is less than or equal to -2 is another vertical line, but this time it's going to be a solid line because it's or equal to -2. And if we're going less than -2, we're going in this direction right here. So based on this, the solution to this system is only where the 2 parts overlap. Well, this shaded region's over here, this shaded region's over here. There's no overlap, so this answer is actually no solution. Nice job today.